Okay, what did I do wrong? So I'm going to use the hint. Yep, I did that. Where'd the 4 go? No way. No way, there was the 4. I circled it and I didn't use it. Oh, you probably saw it the whole time if you watched part 1 of this video. Oh, why did I do math in pen? Okay, so there's still a 4, still a 4, still a 4, still a 4. And we multiply both sides by 4 so that x plus 1 is less than or equal to 4. And then we minus 1, minus 1. So we have, that should just read, I'm doing math in pen, oh my gosh. Okay, negative 4 is less than x plus 1 is less than 4 minus 1 minus 1. Negative 5 is less than x is less than negative 3. Whoa, wait a minute. Okay, back on track. Back on track, sir. This is correct, but there are 2 choices. Okay, first of all, I know right now just by looking at it that both A and B include negative 5 in the interval. So do we include negative 3 or not? I guess what we need to do is we need to take negative 3 and make x become that number. So rewriting the limit, not the limit, rewriting the series itself, n equals 1 to infinity of 3 times negative 3 plus 1 to the n power divided by n times 4 to the n. You see what I did there, right? I took the 3, that took the x, and I substituted negative 3 for x. The reason for doing that is because we're testing to see if x actually makes the series converge or not. All of the numbers between negative 5 and negative 3, including negative 5, they make the series converge. What we want to know is, does negative 3 make the series converge? So we're going to push this forward far enough to see what we get. Simplifying, might as well reduce what's on the inside. So still summation from n equals 1 to infinity. 3 times negative 2 to the n times 4 to the, I bet I could rewrite 4 to the n nicely. And I bet you I couldn't. Okay, so no, I think I can. I think I can write that as 2 to the 2n. Yeah, tricky. Here we go. Let's see if my algebra skills are as strong as I feel like they are. 3 times negative 1 to the n times 2 to the n. Oh, the 3 can travel out to the front. Times n, now ready for it? 4 to the n. That's 2 squared to the n, right? 4 is 2 squared. But then 2 to the 2n, you just multiply, right? You just multiply. So I can write this as 2 to the 2n, which means I can write this as 2n squared. Ooh, check it, big brain move. Which I can write as 2n times 2n, just because of all the 2's that are getting thrown around. And now I can slide my paper over so you can see it. Yeah, let's check. So this is n plus n, which is 2n, n times 2. 2n, 2 times n. Yeah, these are all the same, and I wanted that for this reason right here, equals 3 times the summation of n equals 1 to infinity of negative 1 to the n times 2 to the n over n times 2 to the n times 2 to the n. Look at that. Those cancel. And I'm left with 3 summation n equals 1 to infinity of negative 1 to the n over n times 2 to the n. There's got to be something about like r value, right? And so I'm thinking like this right here, the limit of this is 0. There's something we can do with the alternating series test. I'm not directly remembering what we get to do with the alternating series test, but I believe because of it, taking a stab at it, I've already used a hint on this problem anyway, that this means that we have convergence at x equals negative 3. So I'm going to choose option B. Final answer, $1 million. Dang it.